Hey guys, welcome back to Home Built, and this week it's time to start having a look at the finer details. All right, guys, welcome back. And those who have been following know that this is the Ferrari and this is the Frankenhauler. Last week, I finally got the Ferrari running again, and I've actually been using it a little bit, and it's so good now. But that gear shift linkage is very sloppy, and I'm not very happy with that because I've got to drop the gearbox. But there's other things I need to do down there, so I might do something with that coming up. And we're not forgetting on the Frankenhauler, we've got more and more things to do on that to keep buttoning it up to get it actually looking more like a completed truck, at least the front end, and then we can get onto the back. But first thing this week is there were still things that I didn't finish on the Ferrari, and I have a new tool to start finishing off some of those finer details. And this is my new machine that I have for the workshop, which I'm very excited about, which is the Carvera Air. So it's a 4-axis CNC milling machine. It's a desktop version. Obviously, it doesn't have a huge print area, but that's fine for most of the things that I want. I am very excited to be able to have a CNC milling machine in just on the desk. You know, I've got the 3D printers, and 3D printers are really good for some things. They're additive manufacturing, but you cannot do aluminium or any metals or anything with a 3D printer, obviously, or not the home versions of it. But this will step that game up. Now, it has an optional 4th axis, which is basically like a lathe spindle that I can add onto it. I'll play around with this later. I'm just getting my head around it for now, but it opens up so many possibilities. So I had to play around with it yesterday, and it's got a bunch of projects you can sort of initially have a look at and play with. This was one of them that was sort of pre-programmed in there. So this is just a block of sort of foam board sort of thing, and it cuts this out, and it's quite fine detail in this carving. It can do PCBs as well, so printed circuit boards, so you can carve out and drill all the holes and do all that sort of stuff with this as well. It comes with a whole lot of different tooling, different bits and different clamps holding down work pieces and all that sort of stuff. So there's lots of stuff to play around with. I spent all day yesterday playing around, getting my head around it, and then designing in CAD and then working out in CAD how to program this, because obviously there's a level of complication. I've already been using CAD to make programs for things like the CNC plasma table. So that's a very simple, basic 2D version, whereas this is obviously much more complicated because you can use a slightly larger bit to go through and take out the bulk of the stuff, and then you have to be able to come back with another tool path with a finer tool to be able to take out the detail stuff. So you've got to program in all of those different tool paths, which thankfully there are sort of tutorials and stuff on to show you through all that. So that is all good. So to start with, what I think I'm going to try and do is I'm going to try and make up some badges for the Ferrari. So I went through my scrap bin. I've got a piece of 6mm aluminium plate, and I'm going to try and first do my home built logo and see if I can make a little home built badge. I've got the program there, so let's go through now and I'll just show you roughly what I need to do and see if we can get this to work.
So the bed of the Carvera is a really clever design, and basically it's got a bunch of screw holes all through it, and you can use the range of clamps it comes with to mount basically anything you like into the bed.
All right, so I've clamped down my piece and I have got my G code into the Carvera software. Let's see if this will start doing what it needs to do.
So the Carvera has a built-in probe that measures the height of your working materials, and also it measures the height of each bit. So as you change to the different bits, it will measure the height and then run the tool accordingly.
All right, well, that didn't work properly. Yeah, it looks like I actually plowed it straight into the deck. So I worked out what I did. I didn't set the multiple depths, so it just tried to plow in and dig the whole thing in one bit. So that is why you test. All right, round 2. Let's give this another go. That's better.
So with the settings sorted out, I just left the machine up to its own devices and came back when it beeped to tell me to change tools.
All right, first pass gone through. So now I've changed over the bit and we're going to go again. Let's have a look.
So I need to play around more with Fusion because the tool paths are doing some weird deviations.
It looks like I messed up again and we broke the bit. So I've set the whole G code again and I am doing it just from this last operation forward. So hopefully I can just do that bit and I don't actually have to move anything because I haven't changed any of my work holding or anything. So it should all be in the same spot. I think I broke the tip off the tool again, but we're going to let it run.
So I definitely need to spend some more time in Fusion learning the different processes and all of the options that go with them because the machine did exactly what I told it to do. I just didn't tell it the right thing to do.
All right, fingers crossed this is the last pass and it will cut it out.
So this final cutout is called the contour function and it actually will leave a predetermined amount of tabs to hold the piece in place.
So I definitely need a little bit more work, but there is my logo. I actually have some little tabs around the edge still holding it in, but it cut it all out all the way. Uses a little bit of wasteboard that goes underneath. So it's actually designed so you can carve into it and not damage the bed of the Carvera. But that is awesome. What I'm going to do now, let's cut this out and give it a bit of a polish. Oh, I don't even cut it. I can just pop it out. How perfect is that? There's my little badge. Let's give this a little bit of a clean up and see how it looks with a bit of a sanding.
It probably would have been neater if I ran a chamfer around the edge of all these bits, but that was another step too far with my programming skills at this stage.
All right, and with a bit of a sand, how good is that? Now look at the detail in that. I need to spend some more time in CAD working out my tool paths and things like that. But considering what this tool is, it's in one day I've got a mill doing custom work. There's a lot to learn about these things and most of the stuff is already programmed in, so it makes life really easy. I want to say a big thank you to Carvera for sending this out. And if you guys think this is a sort of thing that you could add to your workshop, there's a link down in the description. Check them out. I'm definitely going to be using this a lot more in the future to make lots of little bits and pieces. I've got my eye on using the 4th axis to make some switch knobs and just a whole bunch of custom detail pieces that I think will really up the game of the workshop. But for now, I think I'm going to give this a coat of paint and then sand it again and polish up the face, and let's see what that looks like, because I really hope that I can make this as a this really cool, shiny, polished badge. Let's go and do that. And as I said, check out the link in the description for the Carvera Air. That is looking fantastic. I think it could use a little bit more cleaning up. I could get in there with a little brush and paint black inside the little crevices where I sort of polished it out. But nice. I will move back onto what I was dealing with last week. You saw me playing around with the heater flat box for the Frankenhauler. And I designed it and 3D printed it out of ASA with 2mm thick walls, and it was too flimsy and it broke. I did it again and I made some modifications, and this is now with 3mm walls. It is much stronger, much more solid. I printed it in this orientation rather than this orientation that I did before. So the layer lines are running this way and it's nice and solid. I reinforced my flap. I put a rod in between it. I made bigger pivots and also a bigger connecting arm to actually control the flap. The only trouble is that where I had all the supports, it's quite rough. So currently the flap is too tight and a little bit difficult to maneuver. So what I want to do is I want to get in there, see if I can sand back some of this texture and get this flap to move nice and smoothly and freely.
So I start by going over it lightly with the die grinder, and then I do the rest by hand just to get it reasonably smooth.
All right, it actually looks like this flap. It just needs more clearance. It's more clearance on the sides, more clearance everywhere. It's far too tight for this application. So I'm going to reprint that, but I think the body is good. The body is looking really good. So let's just double check, bolt it into the truck, make sure it lines up. One of the other things I did is I altered the angle of this tube here because of how they were coming out. This one was going to work better coming out more horizontally rather than up at an angle as this one because of where the wiring and stuff underneath the dash was. So let's test this out in the truck now and get on to reprinting that, and I'll see in a day or two what the flap looks like. All right, that fits in well, and yeah, nice and solid. I am very happy with that, so we can move on back to the front of the truck. So, next task is, you saw me start playing around with a flip front bonnet conversion for this truck, and I started installing it before I painted the inside of the bonnet a while ago. So now I need to install the rest of the pieces for that and see if we can get this flip front to flip.
So I'm working this out as I go, but the first thing I need to fit is the slider rails for the back of the bonnet. And this is a reasonably well thought out kit. So there's slider rails on either side, and then there's a hinge at the front that goes into some holes that are already there, or at least the front ones are. I remove the bits that I painted previously, and then with a bit of grease I mount in the front hinged bracket. And once I'm happy with the location, then I drill in the rear holes. And then I mount the rollers into the pre-existing holes on the back edge of the bonnet. And then with Mrs. Jeff's help, I mount the bonnet back onto the truck, but realise I need to do some adjustments. So I wrestle the bonnet back off and then adjust the rollers to try and get them to fit. Time for the bonnet to go back on the truck and almost tip it over the back onto the truck. Then I have the fun task using brooms as props to try and bolt the hinge bracket up to the bonnet itself. Alright, well that was a bit of work, but you can see here that the panel gaps are not amazing. It's definitely a good thing that I am making this a patina truck, because getting this to fit perfectly is going to be a bit of a challenge. I'm not worried about the front alignment, that can be adjusted, but it actually seems like the rear edge of the bonnet is too wide and it's sticking out too far. So what I want to do is I want to get some straps inside and see if I can clamp it together, which will push the center up, and see if I can get it to fit better to the cab. So here I'm getting a ratchet strap and wrapping it around the bonnet and ratcheting it really tight as I can sort of get it, and then using a dead blow mallet I'm going around and just knocking the center up so I can try and curl the bonnet around more and get the sides to come in and the center to come up to get that better fit. Then you can see here I'm using a pry bar to do the same thing and lift the center up. With most of that looking reasonably good, I need to get the bonnet to sit back further, so I'm taking it off and removing the brackets and elongating the adjustment holes so that I can slide the bonnet back a little bit further in the bolting adjustment, and fingers crossed I can get it all to sit on nicely.
All right, that fits much better. It's not perfect. It's a long way from perfect. I mean, this bonnet's not that flat. There's a blow there, but that is so much better. That fits much, much nicer here now. The front guards I need to pull in, and this side is also sitting much better. It still sits proud a little bit, but that is good enough for the moment. So I think we need to move on to something else. All right, 3D printer is finished. Let's see if round 3 of this flap is actually going to work. It's still a nice tight fit, but it's quite easy to manipulate with the little pin on the side. That is perfect.
Now just need to bolt on the Bowden cable and give it a test fit. And the end of the Bowden cable is held on with a screw that goes all the way through, so it's not just held on by a little plastic tab.
Works perfectly. That is fantastic. It does exactly what it's supposed to do. Oh, I love it when something like this just works. That's really simple. It's perfect. So I'm going to mount this into the truck now. I have to come up with some sort of valve. I'm thinking maybe a knob that I can just turn backwards and forwards to get the vent to open close, because a slider won't really work in this era of truck. But that's something I'm going to have to have a think about and come back to later. But we can just bolt this into the truck now and call this side of it done. Okay, so last week I got the intercooler pipes in and that was all set up, but I hadn't worked out an air filter yet. I did some measuring. I put an order in, and Raceworks sent me out a bunch of the silicon bends, and also this, which is a BMC direct air intake filter. So you can't have legally an open exposed pod filter. It's a legal requirement, but I believe this counts as an enclosed unit, so I can sit this down, and I need to make a mount for it down underneath the intercooler pipe down here somewhere, and do some plumbing for that. So let's get a filter on the turbo.
So I found two 45 silicon bends. One of them is actually a reducer to get to fit the end of the turbo, and I'm using a bit of 2-inch tape here to wrap around the edge of it to get a nice square cut on the silicon. I then use a short piece of aluminium tube between the two silicon bends, and then just connect it all up. And I just bent up a simple little bracket on one side of the air filter, which holds it nice and firmly in place.
All right, so I've got a couple of silicon bends to get it away from the alternator, and then this is mounted in now. It's nice and solid. I've got a bracket joined onto the side of the radiator. So we have an air filter. That is another job ticked off of the list. All right, so the next thing I'm going to tackle is my radiator currently is completely empty. There is no coolant in the system at all. That is because I want to sort out my heater side of things. And I can't remember if I mentioned this a couple of videos ago, but when I first looked at this system, I mentioned it, and some of you guys suggested me get one of these, which is a 3-way heater valve, which I didn't actually realize was a thing. It's got 4 inlets and outlets, so it basically goes in between these two pipes, and you can either set it up so that the coolant can run in through this tube and up through into the heater core, and come back out of the heater core and come down and out the bottom here. But if you flick the switch, it switches it off, and the coolant is open to go up into the heater core, but it's not really going to go that way because it can't come out. So it just can go loop over the top and come straight back out the bottom. So now I've got to fit this in and see if I can mount it somewhere where I can connect the Bowden cable to it, and it won't look too out of place. So let's see if we can work something out.
So unfortunately, because of where I need to run the Bowden cable, I couldn't hide this valve away in the engine bay. But you can see here, I went to my local auto parts store and I found a little length of heater hose that had a couple of nice 90-degree bends on it. So I used that to cut up and at least have a slightly nicer run coming out of the firewall. And then it's just a few hose clamps to connect it all up. Then it's locating where my Bowden cable needs to go. Drill a hole through the firewall with a rubber grommet. Feed the Bowden cable through and connect it up to the valve.
All right, that is not pretty at all. It's a bit of an abomination. I don't know whether I can make a cover for it or something. I sort of had to mount it up high because it's the only way I can get a good run with the Bowden cable going across to the dash. So it's all a bit of a compromise, but that will have to do for the time being. All right, well, one thing I can do to disguise it a little bit more is I think I can mount my washer bottle over here and sort of add it into the mess. This is another Raceworks unit, which is really good. I like it because it's already got the motor already plumbed in. So it's just a screw it, mount it on. I've already got the wiring set up from the original bus, so I can run the wiring through, and then all I have to do is actually get some washer jets because this truck never had them. So that's something I'll add in a bit, but I'll put this on now, and at least it'll sort of help disguise my ugly heater hose situation.
Definitely nicer to disguise my ugly heater hose with a nice functional bit of gear. And you can see here I am using riv nuts because I don't want to weld onto my nicely painted firewall.
This truck just keeps giving me curveballs. So I've made my mounts up and I've mounted my tank, and then I remembered this truck is 24 volt, isn't it? It's not 12 volt. And this little washer motor that comes great with this kit, perfect, is 12 volt. Now, this is actually the washer for that was on the bus. And you can even see down here, it actually says 24 volt. So the issue is that there's no super easy way to connect this pump into this washer. I suppose I could drill a hole in the side and just put a rubber gasket and some silicone in there. That may be what I end up doing. But for now, I might actually run this pump until it doesn't want to run. See how this little 12 volt pump runs on 24 volts. It's probably going to fry it pretty quick, but for the time being, I don't even have washer jets. So let's just mount it up and worry about the pump itself later.
So it's drilling another hole through the firewall with a rubber grommet and feeding the wires through, and I had to cut the plug off of the end. I couldn't get the terminals out of the original plug. This way I can have two different pigtail ends, one for the original Coaster 24 volt pump and one for the 12 volt one I'm going to burn out very quickly. And that looks nice and neat.
All right, we're getting very close with the engine bay now, and one of the final things that we need to still sort out is with my radiator cap, there's actually no overflow bottle. I didn't get the overflow bottle with the radiator. I can't remember what happened to it, and either way, Raceworks do a much prettier unit. This is going to be a much nicer version. For those who don't fully understand what these do, basically, in this case, we've got the radiator cap here, and my rough understanding of how things work is with the radiator cap, these are actually like a two-way valve. So as the coolant heats up in here and expands, it will actually push it out of this hose. And if it was just open to the ground, you would lose that coolant. And then as it cools down again, it actually opens up and sucks back in. Well, what happens is if you have this tank, it will overflow and push the coolant into the bottom of this tank and fill it up. Not much at all, but generally you have a little tiny bit of coolant in here. Any expansion goes into this tank, but as the truck cools back down again, this one-way valve will open up and it will suck back in coolant from in here. And this is a system so when it gets up to a certain height, it'll overflow and just come out the bottom. So if it really has way too much, it'll just overflow and dissipate out. But this keeps it all enclosed in the system and keeps a nice sealed system. So I need a place to mount this. I'm going to mount it right down here next to the radiator. I think that's going to be a good spot. So let's make up a bracket and mount that and get another job marked off the list.
So to quote Richard Brunning, it's time to make a bracket. So I trace the mounting tabs onto a piece of sheet metal and trim it out with a bench shear. Give it a 90-degree fold. Mark and drill out the mounting holes. Then add a couple of captive nuts. Quick coat of my favourite black enamel. Bolt it all into place. And then cut and fit the breather hose.
All right, and we have the overflow tank in, and that is really starting to come together. I am very happy with the progress in here. There's only really one or two more things I need to do in the engine bay, and then we are done and sorted with that, and we can just start getting on to the rest of the cosmetics and that sort of stuff. There's a little bit of wiring and a little bit of things, but not much. But that is all the time we've got this week, so I think that means it's time for Fun Facts with Mrs. Jeff.
Hey guys, in 1956, after an 8-year hiatus, Lincoln revived the Continental name with the Mark II. At its launch, the Continental Mark II was the most expensive vehicle sold in the US by a domestic manufacturer, rivaling the Rolls-Royce Silver Cloud. At $10,000 US, it cost about the same as 5 Ford Custom Lines. It came standard with power steering, power windows, and power seats, and the only option was air conditioning at $595. Each vehicle was hand-built, and its styling was more subdued than the popular Fender cars of the time. The only bulge apparent was in the rear of its boot, and that was the spare tyre. In total, 2,996 Continental Mark IIs were produced before they were discontinued in 1957. And it's estimated that due to their hand-built nature, Ford lost approximately $1,000 on each car.
All right, and another week down, and I am very happy with the progress where it's really starting to feel like it's an actual truck. Shush. We have assistants, 2 of them. I want a quick thank you to... That's one. There's another one down there as well. This is Minka. There's the other, which is Shorty. But again, thank you to John Mullins, who's the plant manager at the Ohio Ford plant. And he sent me out this as a token for the wall off of the new F550s, which I think is as close to what the modern version of the Frankenhauler is currently at Ford. So thank you very much, John. And yeah.
And as always, subscribe, like, comment. It's Patreon. See the videos a day early with no ads. Sorry about the groaning. That's coming from the other dog.
Here we go.
Oh, one in each.
There's 2. All right. See you guys.
Hi guys. Bunnies. Puppy girls. They're hungry. You're hungry, aren't you? They're hungry. I'm thirsty. By crikey, she did it. Rivaling Rolls-Royce Silver Cloud. Rolls-Royce Silver Cloud. It cost about the same as the 5 Ford Custom Lines.
No.
Well, that's what you've got.
As 5 Ford Custom Lines.
Oh, I didn't get that. No, I was thinking it was the name of the car, so I didn't understand. That's what I was saying.
Yeah, that's why I'm like...
At $10,000 US, it costs about the same. Stop looking at me. At $10,000. At $10,000. And its styling was more subdued than the Fender monstrosities of the time. Than the popular Fender cars of the time. With the only bulge visible in its rear. With just a prominent spare tyre bulge in the rear of its back boot.